Okay, so this session is Android parent meeting. Did I get a volunteer to take notes with Gabi? I haven't got it set up myself, and I'm running a distro, so thank you for having me. Okay, I appreciate that. And if somebody let me on the secret here, the name is Ubuntu UDS 1 7. Is that the? Okay, I might as well log into the room then, just for drill. And there was some problem some minutes ago about Gabi having a heart attack, but hopefully they got it back up, the server back up.
It's chronic.
It really is.
It's chronic.
I could suggest something like VNC or one of the ancient things like that these days.
It's usually not that bad.
Oh, okay. So I'm filling in for John Stoltz. He couldn't be here this week, so and he's been doing some work involved with it. I guess what I'm going to do is give a little bit of an overview of what's going on, or what the deal is. So the idea is not, repeat not, for us to try to take over Android.
Just 1 second, Paul.
Go ahead.
Do you have the note taker specified?
The gentleman back there.
Okay.
Contingent on Gabi working. If the fallback if that doesn't work, because there's always Emacs VI and all those things locally.
Okay, thanks very much.
Okay. I'm old enough and I'm never afraid to get it worse than necessary. If that phrase means anything to anybody anymore. From back when cars were new and unusual. So if you saw somebody stuck or broken, you yell out, "Get a horse," right? Okay. Right. So we're not trying to, there's several things we're not trying to do. One of them is we're not trying to produce a Monaro branded Android distribution. Okay, again, people can get that from Android. There's not a whole lot of value you can add there. Now we may have our own internal thing we use to verify that our changes don't break things, or identify ahead of time if there's some incompatibility with changes they've made and the changes we're making, to get a heads up and see what's going on. We are not going to be doing a huge rapid development. We have a lot of people on Android, and it's not we're not trying to, our main focus isn't Android. Android is very important to us because there's a lot of Android running on ARM, and so part of what we want to do is help a little with that, but it's help a little bit as opposed to be the major contributor. All right, so there's so if you take a look at the technical topics webpage, there's 3 major topics. There's upstreaming, there's common tree, and there's demonstrating features in Android. If you've been following the Android soap opera, I guess might be a way to put it, with the Linux kernel enable list, there has been a little bit of resistance to a number of the Android features. The one that I've been most closely involved with has been suspend blockers. So what happens, Android has a number of patches that they have. Some of them they've tried to get upstream, some of them they're just sort of there. And one of the things that would help our members quite a bit is to have more of the Android function upstream, to make it so that it tended to be more tightly integrated with the other kernel work, and so that there was less work required to get an Android going with recent hardware, for example. Yes?
I just have a quick question.
Go for it.
So, obviously, you say you don't want to make an Android distribution with an Monaro sticker on it. That's fine. Yeah, that's right. However, from the kernel side of things, do you think it's worth having a sort of an Android-flavored Monaro kernel, or not?
But certainly for internal use.
I mean, because if you're pushing the stuff upstream, or trying to push the stuff upstream,
we're helping them push the stuff.
Okay, yeah, there is a difference. So if you're helping them push it upstream, are you going to be early adopters of these patches as well, or are you not going to? Are you going to wait right until they've all gone through to mainline and say, okay, you've made it?
So I think what will happen is that for different patches, the one that we've looked at mostly so far has been the suspend blocker and the wait block patch. But I think as you go from patch to patch, you'd say, all right, it's kind of like you have to look and say, okay, what's the status of this patch? So it might be, for some of the patches, they just haven't tried yet. Others of them, they've tried and have gotten whacked in some cases repeatedly over a period of a couple of years, in cases of suspend blockers. And so then in that case, you say, all right, well, what, you look at it and say, okay, if we look at the flame wars that have gone on, what problems have they had? One big problem was with the spend blockers in particular, was that neither side knew what the other one was talking about. And so any actual agreement in that situation is strictly coincidental, right? And probably not real agreement. So we went through one thing where, go ahead.
I think maybe what Will's asking is, maybe not suspend blockers,
Yeah.
some of the patches Android is carrying, are we going to put them in Nicola's ARM next to him? Or
Or
are we
I would envisage a separate branch.
Oh.
We did,
No, I don't think we can put
We
them in.
don't know yet. I
Yeah,
think
I think-
whatever
yeah.
sensible might be the right thing. But I think the topic here
Well-
is more about what of those patches, what of those kernel-y things could we usefully promote or help.
So let me answer it a different way. Will we like it in Nicola's tree? The answer is yes, but. We wanted Nicola's tree because Nicola comes from pulls the stuff from upstream, we want them upstream. Okay, unless there's some reason to it, there may be some cases where there's a reason to them. For some cases, we might put the patches into Nicola's tree before other upstream, but that would not be I wouldn't think that'd be the common. I haven't seen have not yet come across one in this area where that made sense. But it might, but not yet. Okay, so for the first one, the Android upstream, the problem is, or the thing we're trying to do, is to help them in some way get things upstream. So usually that means figuring out where they're having problems with resistance. I mean, it's a popular platform, so there'd be a reason for it not going upstream. And in that situation, helping work out how to move things forward. So in the case, I'm going to use suspend blockers as the example in most cases. They're not the only patch, it's maybe not the most important one for some things, but it's the one that we've had the most experience with. And it's also the one that they've had the most trouble with. So Google being who they are, they're going to be more happy with Valve if they know they're in trouble, all right? And they know they're in trouble with suspend blockers. They don't necessarily know they're in trouble on the other things. But, so the first thing we did was try to make sure that the people participating in the conversation knew what they were talking about. In other words, get the requirements Android was trying to solve laid out, which I think we've got that, a first round of that done. And the second thing is, the thing that we're working on now is to help, for the suspend blocker patch in particular, help work out, I mean, right now the situation is that it's used in Android and nowhere else. If that persists, if it's never used outside of Android, then its path to mainline will be long and difficult. Because there will always be the objection, well, that's only for Android, so why would we bother taking it upstream? It just produce instability, and it won't help anybody else but Android, so you guys keep the patch if you really want it. We don't believe that's the case. We believe it's something that could be useful for other people. But the way things are set up, the people in the kernel community other than Android are not in the mood to think of other possible uses for it. Okay. So we've identified a couple of them where it might be useful in a desktop system. And that, one of them is, for example, if you had a desktop system and it wasn't being used, having things power itself off might be a good thing. Except if you, for example, needed to have it back up at 3 in the morning. It would be totally unacceptable for it to power itself off at midnight when you left alone, and then not do the backups because it wasn't powered on. All right. On the other hand, if you just leave it there and you don't want it to suspend as quickly as an Android was, you don't want it to disappear in a few seconds, but if after 15 minutes of inactivity it powered itself off, that might be okay, or suspended itself. In other words, when you start it back up, it comes back to where it was. If it would start itself back up at 3 a.m. if it was turned off and do the backups that it's supposed to do. And so
Then you're getting into feature interaction problems.
of course, any feature.
You need a grander scheme to marshal this thing.
Mm-hmm.
So a PC is not a phone, right? So a
That's
phone,
right.
you're not expected to have a compilation or a backup starting at 3 o'clock in the morning.
That's right.
So the hole is getting better, and bigger, and deeper.
The hole is getting bigger and deeper.
Yeah, because you have, like, you're adding something, but then you're creating other problems.
Well, that's the whole point of the work item, is to solve that, right?
Yes, but again, I mean, you'll need a grand scheme to marshal all these things, just
Okay.
like the compilation, and
So and we're doing it step by step. Okay? Because we start with a grand scheme, we'll produce something that's really big and complicated, doesn't actually solve the problem. So we have to start with the problem. If we don't start with the problem, we don't know if we solved it.
Even if we agree that the suspend lockers wouldn't be interesting for other mobile users than Android or desktop users, it would be still very nice to have the drivers that the Android T3s have in mainline, and they won't get mainline if there is no suspend locker infrastructure. So if some Android vendor does a new touchscreen driver, the others can't use it.
Yep.
And if we want to make life easier for everyone, we should get all drivers as soon as possible to mainline.
And that's the reason why we're motivated. I mean, so it doesn't help Lenaro. It doesn't help Lenaro to make desktops work better. That would, having some reason why suspend blockers work for desktops would be a way of solving that problem. In other words, if there was a reason why a larger community outside of Android cell phones because what they'll say if you drive it, what that's already happened is they say, okay, well, stub out the suspend blockers. And then the driver will work in a non-Android, non-suspend blocker kernel. And then the Android guys provide a thing to guide it. Then you get tangled up in people not wanting the subbed out version, or wanting to act and look in a certain way, which is where they're at right now with Power. Okay, so back to your question.
oh, it's not a question, it's just a comment.
That's fine.
Right.
Back to your comment. I'm happy
Because
to
I saw this coming as a big freight train at me,
And you in particular.
no, but that's, right?
Sure. It's been a big freight train coming at us for a long time,
Okay.
for about almost 2 years. So one, and there may be other ways of doing it. And so other ideas or other approaches would be welcome. The thing that Jarla's been doing is to say, well, all right, so how you know what, suppose he started with the problem, okay, I'd like my server to shut itself off when it's not using it. You know, in fact, his exact statement was, I live in Portland, Oregon. We care about energy conservation. So I want my machine, if I'm not using it, to shut itself down completely. Yet I want my backups to do it at 3 in the morning, and that's what he schedules over there. All right, so given that he wants to do that, he has to have some way of waking it up.
Excuse my ignorance, but
Sure.
with a phone, I'm sure it goes into some power type thing, but you get a call at any minute, right? So it has to be able to recover from that.
And what the phones do is there's a little bit of hardware, not the main CPU.
Okay, so
It's
there's
just
just
extra.
extra.
So it's active up, and that's one way. And so if you suspend it with this, you have to have some way to wake things up.
Yeah.
And this is why we focused on this one, because the first thing you have is how the heck do you wake a PC up if it's suspended, right? It turns out that almost all PCs do have that capability. And there's something called a real-time clock. Why they call it that, I don't know, RTC as they abbreviate it. And it's a special purpose thing, it's not standard, it's just there. And some applications know about it, and they will in fact poke it with some binary value that they know on that particular PC. It will cause it to wake up at such and such a time and then power things off. It then comes up and they can do things. So what he's doing is integrating that capability into the POSIX clock framework. So there's a clock real time, a clock monotonic. He's putting patches together that have been submitted.
Who's E? E?
John Stoltz. So I'm kind of channeling John Stoltz for trying to do my best at it since he couldn't be here again. So there's a clock monotonic and a clock real time and various other clocks already exist in POSIX. What he's doing is he's adding a non-standard extension, a clock under our RTC. All right. And so what you can do as an application at that point is use the standard, regardless of what hardware you're on. Again, the actual RTC registers vary from PC to PC. So what he is doing then is making it so that you can just do the normal POSIX operations on this clock RTC. It will then aggregate all the requests. One of the shortcomings of PCs now is that if you have two applications trying to do it at the same time, they'll stomp all over each other. One of them will win, the last one will win. And then what would happen then is that it would program the RTC to wake the system up. And then At that point, there's a bunch of questions that you have that could be addressed and solved. I mean, until we have something to wake the system up, there's nothing to do, right? But there's a number of things like, okay, if I'm running a compilation, do I want the system to continue until a compilation is done? So in other words, am I doing something important? You have to have a way of designating that.
It seems to require some sort of foresight to say, I know I'm going to want to wake up, rather than a reactive.
Sure.
Yeah.
So cron is one thing that does that by default now. It doesn't say wake you up, but it says, I'm going to do something at this time. You don't necessarily want all your cron entries to do that. If you had something every minute went and did something, but you'd have to classify it. So that's a next step out there somewhere. Is okay, if we were to do that, what other things need to your point, and whatever you want to call it, what sorts of things need to do that? So one option would be to have a type of cron thing, a mark. There's different little qualifiers. I mean, until a couple months ago, the last time I did the cron and page was back in the 1990s sometime. It has changed a lot.
Yes, but for cron, I can see that you have a deadline for some future time. What about an obvious case you might want to wake up as a keyboard interrupt? How do you cause that to via the RTC?
Well, that would be a different thing. RTC is based on time, just like on an Android. There may be time-based. There's a incoming call that will wake it up, and then depending on the Android thing, maybe touching the touch screen, or there may be a special button you have to say, "Hey, I know you're asleep. We'll wake up now." So you'd have to. And the thing is, that's why we have to start from a known problem. So John's going to solve his known problem, which might not solve yours. Okay. So he has a server. So he does his kernel compilations on his local machine. So he might, he's looked mostly at the time point at this point. He might also need to do a wake on LAN sort of thing, right? So that you might have to have something that, if the thing isn't there, send a wake on LAN packet and make it wake up, kind of thing. At that point, his local laptop would be worried about, is there a kernel compilation need to be done? And then there would have to be something to, if the thing isn't reacting, make it wake up. But the current, if somebody has some suggestions on how to make the wake on LAN thing go, that would be a good thing to bring up at this point. The current work item is strictly the RTC, bringing RTC into the POSIX clock API, so that things like cron and things I think it's at least concerned about would work. And then over time, if it turns out to be something useful, then there would be any number of other things that need to be worked out. So I guess where we're at this moment, the RTC work is ongoing. There is some kind of work, be it cron or something else, to register to make a more user-friendly version of that. John, being who he is, he probably just uses the kernel interface and set it up manually with some special thing that knows about it. But you start at some place, and as different people with problems come along, you expand it. And then any number of other things. In a different situation, in his situation, the server is only busy if somebody's talking to it. The exception being the backup. So he'd have something set up for the backup to say, I'm important, so fire a wake lock, and then the backup finish, let go of it. But other situations, there might be some other API required rather than doing it by hand. But I guess the one question is, are there other use cases that people have in mind? The ones that, the main one that we've worked out so far is the make a backup happen on a server with power on.
I've looked over the Android patches a number of times, so there is all kind of other weird stuff. I mean, wake locks is one thing. There's the opportunistic suspend as well. I don't know where that is standing right now. Or it's early suspend was the first name. Now it's opportunistic suspend. And those two work a little bit hand in glove. So you have to have So I don't know if anybody's looking at the opportunistic suspend at all.
The, inside of an RA.
Yeah.
Okay, that would, those two have to work together for the RTC application to work. In the kernel community, Raphael Masaki and Al Stern have been
Yeah.
looking at those.
I looked at the other patches as well, so mainly that's a lot of Qualcomm patches. I guess Code Aurora is taking care of that. There were some assorted patches to all kind of weird stuff. I brought 2 of them into 2647 now.
Cool.
You can actually just take, if you see something that's a few lines and they have just kept it private, you can just take it out and send it upstream. And that's decreased the patch stack, at least for vendors. It helps to some
No, that's a really good
microwave
point.
degree. Then
They
they
don't
have
have any member of the kernel, so I haven't done that.
no, then they have some weirder stuff in drivers that got merged to staging at one time and then reverted.
Yep.
And that's mainly Ashmem, PMem, and Binder. And all of them are Ashmem and Binder is BOS stuff, more or less. It's things they have, if I'm allowed to be a little bit harsh, it's more like these people come from BOS, so they like to do things their own way. And they said, I discussed it with Brian Sweat one time, this Binder thing, for example, and he says that, yeah, basically it's dbus, but we like Binder better. And there's some acceleration work being done for dbus that sort of puts a special socket in the kernel that will have more or less the same, bring the same latency wins they have with Binder into the dbus as well. So
the kernel work is quite hack at the moment.
Yeah.
I'm not sure if it's going to be easy to make it something that is clean and acceptable by mainline developers.
okay, so that might be something we should work on.
Yeah, it could be a good idea to work on.
The dbus.
Which work is a hack? They work to make dbus faster as a hack?
It's based, it's
Kernel support for
kernel
dbus, basically.
Okay, that's a good.
It's a point-to-point communication instead of mediating through a debug.
Because if they get the same API, I think they're happy, although I haven't talked to them about it to know for sure.
This wrapping their Binder thing into dbus is a much bigger problem. We won't ever do that, I guess.
Okay.
But at least providing an IPC mechanism that is comparable and standard.
I know a lot of people are unhappy of the dbus performance and latency, so
I think this patch was tested on the M900 and it was significant.
yeah.
So it's a good thing to work on.
Yeah, if it helps.
So this is a bit more around how to make dbus better, then you might be able to convince Android to make it better.
Yeah, but more or less I've looked at this Binder driver is very sort of, it's not very many lines of code, it's just a lot of corner cases, so it's actually possible to wrap Binder into dbus, but it requires a lot of knowledge about Android and testing all this weird user space they're doing. So if you're an Android person, you can probably do it, given enough time. I don't know if they would accept it, even though they have dbus and Binder in parallel in Android, which is another peculiarity. They have 2 IPC mechanisms.
What's the other one?
Binder.
Binder is the Android flavor, and dbus is the internal kernel.
Yeah. They like to think about it as something very special, but we're all very special. Just like everybody else.
Well, help works in both directions. So help is in terms of, as you said, getting individual patches in or getting some functionality in the does wait blocks and send blocker is one thing. Another version of help is getting them to see the value of using existing functionality that does the job for them. Right?
PMem is another thing. It's pretty dangerous, I would say, because it's
Well, this is user space access to physical memory.
yeah, it's user space access to continuous memory, more or less, or to persist. I don't know what P is for. Physical memory driver. So giving user space access to physical memory, especially for media accelerators, this stage fright and Skia, and that's stuff they're doing. And the problem with PMEM is that it encourages driver writers to use the PMEM buffers to pass data into their accelerators and never ever go for the proper frameworks. So I've seen somewhere that PMEM is used instead of investing time in doing things the proper way, like using GEM for graphics memory, for example, or things are being pushed to PMEM because it's more convenient and available right off. It's a simple way to get an interface from user space into physical memory. And that's not good for the community, that a lot of companies is investing time and effort into that instead of working on proper interfaces. So I don't know if we could do something there, or if it's a multimedia item. Or
We do have a separate item, but I don't know, sorry to discuss it, I just showed up this morning, so
and we had something yesterday.
This was on the contiguous memory?
Yeah, continuous memory, and it relates to many discussions. Whether it's continuous memory, or if it's part of the DRI, DRM, or discussion, or wherever it fits in. It's mainly being used for that.
Okay.
But the Google people are actually encouraging platform vendors to use PMEM, and that's I see that as this is not so good, to put it in a diplomatic way.
It would be, that may be the case. So again, in the case of suspend blockers and boundaries and extend, my focus of my help has been to, well, one was to help both of them understand what the others were saying. That didn't make any happy with each other, but at least they're specific about what they were happy with, I think. But other ones, as you say, are getting the function needed from kernel. The other one is convincing the Google Android people that they should adjust to what the kernel is. And I'm sure that we'll have plenty of fun and excitement on all those fronts. Okay, so we got the binder patches. We talked about suspend blocker wake blocks, PMEM. Are there any other major ones that people have done thinking about? Okay. All right. Another piece of it. So that was one piece, helping things get upstreamed. A second piece, the second of the sub-requirements, is having a common tree. This is something that's not particularly high priority at the moment. The purpose of it is not, again, to try to make Android tree from Monaro externally visible. There's not a whole lot of point in that. But it might be helpful in testing our features. For example, from the session earlier this morning, was talking, one of the things we talked about was Thumb 2 support in the kernel. So maybe it would be worthwhile to have a tree within Monaro to test out our Thumb 2 support patches and make sure they're working with whatever Android is doing. I wouldn't think that the stuff that we've talked about so far would care about the instruction set, but you never know until you actually try it. Again, this is fairly low priority. It's something they can do as well as we could, but we may, for example, if we were getting to a point where we wanted to talk to them about taking our Monaro patches sooner rather than later, one way to help with that conversation would be to say, yeah, we tested out the tree right here, see, as opposed to, depending on what the motivations were on both sides. So that's so again, if we're going to do trees internally, we might do an Android tree internally. If we did, there'd be some reason like that for it, as opposed to Truth and Beauty having all trees. And another item similar to that is demonstrating the feature of the kernel in the Android tree. Again, if we were wanting them to be more aggressive about taking our things, we want to have some features in mind and have some demonstration of that capability. And again, I'll throw out Thumb 2 support as a possible thing we might want them to help with or to make use of. But again, this one's reasonably low priority, but it's we're capturing it for moving forward with that.
They have their own copy of the compiler as well. I don't know if the toolchain group may be interested in pushing the compilers.
And if they were, I think that is one of the things that's being considered. Yeah. But if they were, then the question would come up from the Android. If I was the Android folks, they'd say, well, yeah, we got to compile the kernels at work. And so then having a tree and saying, yeah, see, we just produced it, we loaded it on this phone, and it's there. and having it as one demo might make sense. Our own internal kernels things, we've got some neon support work that they might be interested in. Maybe they do their own, I don't know. The contiguous memory would be another one if we were trying to get them to not use Peanut and use contiguous memory instead. Showing that is built into an Android, showing that it can do something might be a useful step along with this. But this one is still we're fairly early in the process on it. It would be something that would be as part of a larger effort to get Android to do something or other with our work, as opposed to acting as a district level. So, any other thoughts on those? That's the material I had coming in. The help get stuff upstream. The having a tree to demonstrate that our stuff didn't break them, and also to demonstrate our capabilities with respect to Android.
So on the Peanut talk, there was a discussion yesterday with Alexander Sakin, as you needed. And they're looking to see what they would do if they would re-implement some functionality similar to that, because that's what people that are doing hardware codecs are looking for. And so if you're pointing out that they're thinking the wrong way about it, then either we need to make a big effort to do some education there, or to understand better what the use case is. And I was actually a bit surprised that they said, well, it's something which is similar to what Peanut is, and I was wondering, well, it's that similar, why would we implement something new and not just use something which actually has some traction already, or at least it's somebody who cares about it already. So I think that's a secondary conversation to follow to come out of that, to just understand better what the use case is.
So what we need to do is get with people that are thinking in terms of keeping them and understand what they're doing and why, and see if contiguous memory could cover that instead.
Right.
The usual problem is that they don't. Oftentimes on the low-end devices, there's no concept of virtual address in the hardware.
Right. There's no system review.
Right.
On this hardware.
And so if you don't have that, then you don't have any choice, and you want to have user-level access to the device. You don't have any choice but to have user-level physical address.
That's right. And not having system review is a common thing on some of the platforms. On some of our target platforms, it's a common thing on these.
Although I suspect there will be on the higher end ARM device, will be a system review at some point in time.
Right.
So we probably may have to deal with both ends of it for a while.
Maybe David won't want to talk to us about that.
Once we have that, the problem with Peanut goes away and all that stuff.
Right, although again, there may be a lot of devices that...
Right now, everybody's having this problem. So.
Right, but that's the thing, right? All the people that are building at the moment have this problem. They say, well, right, I have this decoder, I need to do 1080p encoding and decoding.
Yeah.
Where do I put the data?
So the system that I've used are on SOC at the moment, the SOC specific.
Yep.
And I did see some patches posted for this a month back to add a framework for accessing it may have been, yeah. And a walk around.
But I think Qualcomm is one of the only SoC that does have a system review.
I thought
I don't think so. I don't think so.
Has IO
You got that? No, I don't know.
Well, either way, there was a framework, I don't know if it's confidential.
Right.
Okay.
It sounds like a lot of people have tried to solve this problem in different ways.
I think that the problem is that it's
Per SOC, it's not prevalent enough that any framework will get traction.
It took a lot of years before x86 had anything reasonable. Things were using their own thing for a while. I'm not sure they really converged yet. But kernel can handle different kinds of IOMUs. It handles different kinds of MMUs, so it's not entirely wrong. Although it's a lot nicer if the IOMU system MMU has something similar with the one for the CPUs, makes your code a lot simpler.
Yeah.
But it's a bigger piece of functionality to put in the SoC. So, okay, so that's a good point. I think the main thing why people think of Peanut is in fact because they don't have a system MMU.
Right.
Okay, any other topics? Again, the three big ones we were looking at were getting things upstream. There's several approaches to that. One, help convince the current community they needed. If it's something fairly extreme and simple and it's in your area, just take it. It's a reasonable thing to do. and they're convinced, the glue guys, they need to do something more similar to what the kernel community is doing. We'll have those three situations happen in all the cases. The second big area was having an Android tree for testing, make sure we weren't breaking them. And then thirdly, convincing the Android people in some cases they need to take our function, tool chain being the one I think the most interested, but there's no other ones.
I've identified people to do it. The second and the third actually require people to take ownership of that, go with the tree and managing that.
At this point, we haven't taken that step. I have it identified as a very low priority requirement. However, if we're getting specific things we want to push at them, sounds like we're mostly working the tool chain at the moment.
I think it would make sense for us to do it. A lot of the SOCs would benefit from actually seeing that there is this tree. It's one of the targets we're consulting, so we can start seeing, okay, if we start putting in hardware support, which is available, which the vendors are providing, we put it to this tree, how much of that tree actually works on our own device.
Okay.
So that's something which we could do independently of Google, because we have this relationship with all different vendors.
Okay.
So I think it is worth doing.
Is there somebody who's worked with the Android tree and would like to do something with that in the room, or?
Will you stay on the same Kernel version, or will you move on the mainline?
I think so that's one of the things that actually, it's a very good question. It's one of the things that I wanted to actually discuss in this session as well. Is it worth thinking about having a trunk Android kernel, which is something which would have additional value on its own, but that would be working through.
You're gonna do some porting either way. You're either doing pile of porting Android stuff to the new kernel, or you're doing back porting the stuff you care about into whatever.
The thing is that forward porting to me just sounds more valuable, because then people say, actually, okay, there's a kernel which is closer to trunk, which has more hardware support, which I can actually do it on this device.
But it's a patch set which we know least, and there might be a decision based on the size of the patch set. So is the only patch set, it's 10 times bigger than ours, then it's more work.
I agree.
So for example, if we're doing tool chain stuff, if we're trying to just take tool chain, I would strongly recommend we stick with Android's kernel version. If we're talking about support from some new hardware they don't have, then, well, how big is the patch that does the hardware support?
If the patches are going to be huge, because we're going to have people that are working on all the SOCs and pulling stuff in.
Well, yeah, it depends on how many SOCs you're talking about. If you're talking about one SOC, then...
No, we're talking about at least 4 SOCs and going up to 6, 8 by next year. And so these are going to have dedicated teams working on them. So I think the churn there is going to be very high. And backporting those changes to an Android kernel, while it has value, it's all we want to do.
Well, that's part of the discussion with Google, though, is who does, somebody's going to have to do some backporting or forward porting of things as time goes forward. How much, I think we would want to have them continue doing as much of that work is reasonable. And again, we're not putting a huge amount of effort on this thing at the moment. Although maybe you're saying we need to think in terms of...
Yeah, I think we should think about it. I think it has resource impact, so we should.
Unless you could change or something, I think for one porting Google patches is quite, it should be easy.
I think so.
Yeah, they're fairly contained. I mean, they're larger than you'd like.
It's probably much more complex than the other way around.
The reason they stay on a previous version is because of the productization cycle. That's really why. It's because they're tied to shipping a product. And that's the reason why they stay on a previous version. But because we say that actually what we want people to do is to work in upstream and to move closer to tip and have those patches closer there, I think that's the right direction for us to be pushing, instead of the direction of backporting.
So I'm going to be in the middle of the session, but there's no current action list. Did you guys identify some things you wanted to do? So I guess the obvious is setting up an online training.
No action. I think Michael could set up the slapper afterwards.
What was that again?
No actions. Let's see if we can codify some actions then.
So I would guess setting up a kernel Android tree to start with a Linux kernel Android or something.
Okay.
But we have to decide.
We've got some things already ongoing with RTC. I don't consider those actions because they're in progress.
Right.
Okay. There's a potential action about seeing if we wanted to have higher level access to the RTC work. For example, it makes sense to do cron or not. I don't think that's in flight. So that.
Okay, actually, let me rewind the discussion. So
Sure.
the RTC thing is my understanding is that the Android guys are streaming one version of the RTC feature, and John
no.
Food has been reworking the RTC subsystems, and they
No.
okay.
Okay, so this is about wake clock suspend blockers. One of the objections to wake clock and suspend blockers, it's a somewhat a weak, in my opinion, a weak objection, given the increasing variety of Android hardware out there, as was pointed out earlier. But weak and strongly held are two different things, right? I mean, so one of the work I have going on is to come up with reasons why, see if there are use cases for other platforms, PCs, for example, for wake clocks and suspend blockers.
Mm-hmm.
So to that, John Stoltz has been doing the RTC implementation. The reason that's related, what RTC does is the real-time clock, it's a piece of hardware that's on most PCs. You program it, and if you shut the system down, that clock still runs, and then it can wake the system up at the specified time. The reason that's important is if you have suspend blockers and wake clocks, it doesn't help you unless you have some way of waking the system up and then suspend it.
Okay.
You have to have, otherwise it just goes to sleep and stays asleep forever.
Okay. So is that what we want to patent this Android tree?
That is what we're, no.
I mean, it's a
So
feature
we
which one
have three topics. We have upstreaming, which is what that is. So in response to rewinding, I was going to the first thing, which I probably should make more explicitly clear. So we are doing some features proposed for the mainline kernel, unrelated to the Android tree, that could provide use cases for, independent of Android, for some of the Android features, in this case, suspend blockers and wake clocks. John is doing a kernel implementation that provides some extensions to the POSIX clock system calls.
So is it fair to say that we, as first action, want to finish the RTC demonstration of suspend blockers in Atomic branch, which we can send upstream?
Okay, I wasn't thinking of that as an action because it's ongoing, but recording it, I guess.
Does that make sense?
Yeah, sure. And then the action I was thinking of was do we want to pursue a higher level interface? Right now you have to write a C program to make the wake up happen. And so does it make sense to put it in cron or something else like that? Some way of saying, normally cron says do this time if you're up. That's the way cron semantics work. If the system is up, then every Friday do this. So you can imagine whether it makes sense or not. I'm not saying we should do this. This would be an example of an investigation. Is there something, do we need a higher level interface? A potential higher level interface would be a tag on a cron line saying, even the system is asleep, I want to wake up at this time.
Would Android use a higher level interface?
Android has its own higher level interface, but this would be a discussion for
proving that it's useful outside of Android.
Exactly.
So
exactly.
You want, as part of this demonstration, you like some user space implementation demo of
the action is investigate whether it makes sense to have a user level application know about it, for example.
I like this idea, it's interesting.
Well,
it's interesting functionality.
Do we want to investigate or do you want to do it? Like, do you think it's needed to convince upstream to take it, in which case we should do it? Or
I don't know yet, which is why I'd say investigate rather than.
I think you might need more than one example as well. So you've got the server backup RTC, that's great, but you think more so the wake on that as we thought about. So then at a higher level interface, at least you'll be able to maybe combine more than one use case into that. That's only going to help upstream.
If the cron, I think having cron know about it would, I think, be much more convincing than having our C program. I'll agree with you there. If that's what you're saying. Yeah, definitely.
I understand what you're saying, that we don't really know whether we need to do the work or not, but it doesn't have me record on action or not. So should we record on action on doing it, or should we just keep in mind that we could do it if it's needed?
Action on doing it. Action on doing it.
Yeah, and so is it cron? Is the elected program cron? Do we try to port cron to use that? But then once?
Let's put that down. If we change our mind afterwards, it's okay.
All right. As long as there's changes.
Yeah.
Yeah.
It's a nice functionality, and we can even if you're half asleep.
We like being green in Portland, Oregon, I'd say. Okay, and then for the Android common tree, I don't know, so we had some, on upstreaming, we had some discussions of PMEM versus contiguous memory. And that way, you were here for that, so you got that there. The,
I think the follow-on action there is
What's-
to meet up with Alexander Sacramento and you guys to clear out what their plan there is. So they actually discussed writing a kernel driver to accomplish something which is similar to what PMEM does, which is give access to contiguous memory.
Yeah, that's quite surprising actually that this game can work. I didn't know they would be doing that. Because we have this scale of
That's the
projects.
kernel interface to it, right?
So there's, the issue we have is whether or not there's an IOMMU. If there's an IOMMU, then there's no point in having, I mean, you want somebody to do contiguous memory, but you don't want to expose physical addresses to the user space. In fact, you don't want to expose physical addresses to the user space, it's just that if you don't have the hardware support, you don't have a choice. So PMEM is for the case when you don't have an IOMMU, therefore you must supply physical addresses.
I think someone should follow up on those patches we mentioned earlier, virtual continuous memory allocator or something. That used an IOMMU if there was one there. I don't know what it did if you didn't have one. So if you'd say you reinvented the wheel, there's a framework there which is already
What was the name again? Virtual?
VCMM, I'll send you an email.
Yeah,
Okay.
it's called Kernel. But I think
I don't know how far it's got, that's all.
So
It should be
there's
followed up.
patches here too.
I just don't know how much you can reuse with that on a system which doesn't have a system.
So that's something that should be looked at.
Yeah.
Investigate, what's the name of it? The what?
VCMM.
DCMM.
Anyone on IRC tool?
So, is it to reference count the, does that provide some kind of reference counting to the kernel that user space is using physical addresses or not?
I know a bunch of patches, I don't know about that one.
Yeah.
The one I know about, which is some ancient thing, what it did was it just reserved memory for the use, and the user application had to keep track itself of what it was using.
Could you actually then free it up? Tell the kernel that you could, remap
In that particular case, the older one I'm talking about, I mean, there's a bunch of different of these things that have been invented over and over again.
Right.
The particular one I knew that the kernel just made it available and gave a mapping for, okay, this piece of physical address, this piece of that physical address. And the user application had to be careful about what it was doing.
Is that no? Oh, with Octar?
I was sorry, so I an additional stick to that fire. But there was also the CMA work that Samsung submitted for contiguous memory allocator. Remember that I shared that with you, Paul?
That's another session.
Yeah.
Yeah?
It's for contiguous kernel memory allocation. It's one of the big topics which probably
So the way that relates to this, kernel, the allocation memory is whether or not you reserve at boot time, which is a common practice now, or whether you have the ability to allocate it and let go of it and then get it back even later. Okay, so once you have that, you have to have some way of having user space get at it, and that's where you get into where it would be related to some of the other things. Okay. So,
I'm a bit low on actions, to be honest.
there's the other, well, there's not a huge amount out of this session. So we've got, talk to the guys doing like continuous memory allocation and see what they're going to do. Talk to Alexander Sack.
That's the one
Okay, good. And then the next action would be to select kernel things we would like Android to make use of that we want to do. Which is
probably brush it. So, did you get an action control?
the action was work with people who were talking to Android to see if there were features, kernel features we had. Okay.
That's the VCMM. Using this system and new stuff. Okay, so combined with the
So that relates to
relates price what the application needs a large number of quotes, physical memory, and you supply that will vary. So if you've got a system memory new actually those bits of memory may not be contiguous with their use, so virtually mapped on your side of the line. Exactly. You haven't got it. You do got nothing.
So, did we have action on the debug part of the Android features thing and features in Android 3?
I don't have any specific ones at this point. I think what we are is
There were two kind of actions. There was a tool chain action which was build standard Android kernel with Android tools and prove it's better. And the other one is, do we need a set of patches against kernel next, or a separate tree, which parallels kernel next, which has got all the Android latest bits in it.
How do we do something to prove it's better part?
Yeah.
well, we use our tool. We get.
We build it and it goes faster.
Yeah, that's the thing. But so you say go faster with Android. Is there a standard benchmark if you do that?
I think you probably run some of the benchmarks.
One thing is what
There are some
doing
benchmarks.
Code 2. One thing we look at the size.
Yeah.
Yes. Okay, the kernel was this big with ARM, now it's this big with Thumb 2.
Well, I mean, there's value just in proving that it actually doesn't break when building that one.
Okay, so building stack is.
Yeah.
Code's not all going to be anyway.
Yeah, no, it's not.
So I was thinking after I finish the lecture, it's actually irrelevant.
Lovely time.
I'll get how I export actions.
Gave me kind of subtitles. I understand it a bit, but I understand it.
We should be too late to not miss the kernel version discussion.
Yes, so right now in the session we're called Battery Influence with Choice of Kernel, so it's the right time to.
Okay.
Well, there was a break, but we used all the time a lot. Do you need a follow-up on that session? It seems like we really managed to reach all the actions, or?
I think again, the Android stuff is not high priority. We're not going to put a huge amount of stuff in it, so I'm not worried about having a fairly small number of actions. Or am I confused?
I'll send it to you later.
Okay. KUL at Linux.bnet.com.
I don't know.
You
can find one that page. That's what I do all the time.
Did I say something? No, I said two systems.